Data science is more than just some industry buzzword. It's about taking large data sets and trying to make them useful or informative, especially for understanding the world or making informed decisions. To do so, we're going to need to use ideas from computing, ideas from statistics, and also domain knowledge that informs what the data really represents. You can't do an analysis in the legal domain without understanding something about the law. So that's what we mean by domain knowledge, is that you really have to understand when you have a data set, some big table of numbers and descriptions, what's really going on behind those numbers and what they represent about the world. So what is data science? What do you get when you combine computing and statistics and domain knowledge together? You get a science that's about drawing useful conclusions from data using computation as our primary tool. And data science, as a practice, has 3 core activities. We'll study them all in this course. Exploration is figuring out what patterns exist in the data. When you have many observations about some phenomenon, what can you conclude about the phenomenon itself? Oftentimes, instead of just looking at large tables of numbers, we'll draw data visualizations because it's much easier to interpret lots of information at once if it's portrayed in some kind of visual way. Once we've found a pattern, we need to perform statistical inference. And that's because some patterns are there just by chance, and some are there because they're a reflection of some underlying process that's really interesting about the world. So the goal of statistical inference is to quantify whether the patterns that we observe during the exploration phase are reliable. If we collected more data, would we see this pattern again or not? The primary tool we have is randomization because by simulating random processes, we can see what kinds of patterns appear just by chance. And if the pattern we observe is not the kind of thing that could just appear by chance, then we can conclude that it's because of some robust or reliable pattern in the underlying phenomenon we want to study. And finally, we'll perform prediction. This is where we have partial information about something we want to know, and we want to guess about the things we don't know yet. Here we're making informed guesses, quantitative guesses, using a discipline called machine learning. Normally, when we write programs, we just focus on the particular logic of what the computer should do. But machine learning is about not programming every detail, but instead using the data to make decisions or choices within a program. So when we write a program, for instance, to recognize speech or automatically translate languages or control a car or a robot, we don't actually write down all the details of what to do, but instead use examples from the world to help computers automatically learn how to behave. And that's a form of prediction, one that we'll talk about in this course. And these 3 stages correspond to how we'll approach the material in this course. We'll first talk about how to identify patterns, then we'll talk about quantifying whether those patterns are reliable, and finally, based on the patterns we've discovered, the reliable ones can help us make informed guesses about the information that we wish we knew. Once you can do all that, you're well on your way to being a data scientist. Now, in the process of doing all these things, it's important that you learn how to program a computer, because computing underlies each step of the way, and learning to program is just an essential part of participating in this discipline.